Hey everybody, we are going to look at how to find inverses for exponentials and also for logs. Oops, missed part of my erasing. There we go. Please get yourself one of these notes templates for this. Big idea here, as with anything that we do with inverse, is first you change f of x to y equals. And we'll write that at the end of the equation. So I mean like this here. I have an example right here. So this is f of x equals. I can write equals y. That gives you brain trauma. You can just do it this way too. Okay, if you don't want to have equals on both sides, that's all right. And then we will switch x and y. So for this equation, I would write x here and y there, and then I'll write the rest of the equation around it. Then we solve for y. Now that I put y in the big old middle of my equation, let's figure out what y is. And last step, change y to inverse of f of x, which will relate our final y equals equation to our original y equals equation. Again, this exponent is not a calculation. This just relates the inverse equation to the original. So whenever we solve this one through for y, which I'll do right now, then it relates back to what's the relationship with this original one. To follow through these steps here for the problem I just started, I can write, well, I have x equals log base 5 of y minus 3. Trying to solve for y, so I do need to isolate this part. And I will add 3 to both sides of the equation, which gives me x plus 3 equals log base 5 of y. And then to figure out what y is, I'll have to rearrange this as an exponential equation. For a logarithm, the base for the log is the base for the exponential. The log is equal to the exponent. So this x plus 3 will be our exponent. And this is a fact family. The only thing that's left here to write is y. So I found that y is equal to 5 to the x plus 3 power. My last step is write this as inverse of f of x. And that's 5 to the x plus 3. The end. This original equation, well, let me not get ahead of myself. Let's finish this big ideas on the left, but this is what we're going to be doing. Hopefully this is familiar with to you because of the idea of inverse where x and y trade places. Also, we've been rearranging so that a log can be written as an exponential and whatnot. So this is what we're doing today. The base of ln. ln means natural log. And depending on your calculator, it could be lowercase letters or it could be uppercase letters. ln, natural log, means log base e. So if you have y equals ln of anything, then that's the same as writing log base e of whatever your argument is. Alternatively, when you have a base of what we're looking for the base for a log, this log, log, is a common log. This is base 10. So when I have y equals log x minus 1 or whatever it is, this means log with a base of 10 when this is blank right here. All right. Also, to rewrite an exponent that has a base of e, well, we'll write it like this with the ln whatever when we rearrange. So whenever I have y equals, for example, e to the 2x minus 6, then we will rearrange this and write it as a log problem. We can write log base e of y equals the exponent, 2x minus 6. And this is a little awkward. We don't usually write log base e, but you can. What you would typically see is ln of y. Also, if you only have one thing you're taking the log of, frankly, a lot of the times you don't see the parentheses, but that's what it means. Ln y is 2x minus 6. These are equivalent equations. As for asymptotes, oops, whenever you have a log graphs look like this. There's a vertical asymptote. Let's say it's here, wherever that is. I didn't put numbers on your graph. That's not all that important, just to explain the idea. There's an asymptote of x equals h for this graph that you have right here. This is a log graph. Alternatively, if you have an exponential graph, that's inverse, of course. So my graph might look like this. And I don't, oh, this is exponential. And I don't have a numbers on this either. I will have a horizontal asymptote, and it'll be at y equals k. The end. This is all the big earth-shattering, super important ideas. And I have one example that's worked. If I were to write the asymptote for this original, I'm gonna zoom in, don't get dizzy. Okay. Here, this original equation, my asymptote is the vertical, because this is a log. It'll be at x equals 0. You can graph that and verify it for yourself. If you just type this original into anything you have that'll graph. My asymptote for the inverse will be y equals asymptote. For the inverse will be y equals 0. You could graph these. They should be a reflection across the line y equals x, because that's an inverse thing. Reflects across the axis of symmetry for inverses, x equals y, or y equals x. Let's write it that way. Y equals x. All right, guys. Let's get some more examples in here. Just beside this one, I have an exponential equation. I'm going to find inverse. Let's see what color we used here. I'm going to try to be consistent with you. Here I have a log, and I wrote it as an inverse. So when I start with log and write it exponential, I'm going to do blue. And when I start with exponential and write it as a log, I'm going to pick purple. Okay, so the second example that I'll work with you is we start with exponential. Let's try not to look at as many things all at the same time. There, how about this? That's good. Starting with an exponential equation, I'm writing inverse. I will write y equals 0.5 to the x power plus 8. And then, because I'm trying to find inverse, x and y trade places. So I trade my x and y, and I write the rest of the problem the way it already was. And I will need to solve for y. Since I'm isolating this part, oops, let's do cooperate, please, computer. I will need to subtract 8 so that I can isolate my exponent, my base with my exponent. So I'll write x minus 8 equals 0.5 to the y power. And then to figure out what y is, to get it down out of the exponents, I need to rearrange this as a log problem. So I'll write log. My base is going to continue to be 0.5. I'm taking the log of x minus 8. And that'll be equal to the exponent, y. So now I've found what y equals. I just need to write that as inverse notation, like this. We will have some problems that we work through, and you'll be given an equation and asked for the asymptote. And you may graph to find that. It would just warm my heart if you could tell me the asymptote without graphing, but feel free to graph. Here in our original equation, my asymptote, I'm going to call that, I don't know what the good abbreviation is for that's like assignment. I don't know. Anyway, I'm just going to write what the asymptote is, and you guys can hang with me here. My asymptote is y equals y equals 8 for this one. You can verify that by graphing, of course. For my inverse, my asymptote would be x equals 8. All right. Hopefully this is going smoothly for you. Let's look at this one. I got one of my funny looking logs. This is a natural log, that's ln. When I rewrite this, I need to remember what my base is for a natural log. So here I have y equals natural log x plus 8, which means log base e of x plus 8. This is isolated, so I don't have to move anything else. What I need to do is trade x and y. I got x equals log base e of x plus 8, and oops, silly woman. Trade x and y, I said, and then proceeded to not do that. Okay, this is my inverse equation, but I need to solve it for y. So I will rewrite this as e to the x equals y plus 8. To solve for y, I'll subtract 8, and I find that y equals e to the x minus 8. So the inverse of f of x must be equal to e to the x minus 8. Make sure that you write this minus 8 not up here with the x. It's not an h, it's a k. My original asymptote is x equals negative 8. My inverse asymptote will be y equals negative 8. I have 3 more examples. Let's get to going. Here, I have an exponential equation. We're writing inverse. I have y equals 10 to the x plus 1 power. If I put x and y opposite so that I can find inverse equation. I got x equals 10 to the y plus 1 power. And then to solve for y, I need to write log. It'll be base 10 of x, and that's equal to y plus 1. So I'm solving for y. I subtract 1, and I find that y is equal to log x minus 1. If you want to write base 10, you can. If you want to use parentheses for the x, you can. But this is the same equation, by the way, as y equals log base 10 of x like this, minus 1. All right. So now that we've solved for x, I can write this as inverse of f of x, and that's equal to log x minus 1, however you choose to write it. And being consistent, we'll talk about asymptotes here. For my original equation, oof, goodness, I have an exponential equation, so I'll have a y equals horizontal asymptote. There's no k on this equation, so y equals 0. You can graph to verify if you need to, or if you like to. My inverse is an x equals h asymptote, so that's x equals 0. Okay, almost through these. Whoop, sorry. Okay, still exponential. We're doing inverse. We will write this as y equals e to the x plus 2 minus 1. X and y trade places, so I get x equals e to the y plus 2 minus 1, and solve for y. I'll have to isolate this exponent, base and exponent, and I can write this equation as x plus 1 equals e to the y plus 2. And that can be written as log base e of x plus 1 equals y plus 2. Log is equal to your exponent. Solving for y, oops. So I will subtract 2, and I get y equals log base e of x plus 1. This is your argument. This minus 2 is at the end, so I have an h. Oop, look out. I have an h here. I have a k here. And so my inverse of f of x is equal to natural log x plus 1 minus 2. If I were to graph my original equation, I could see an asymptote at y equals -1. When I look at my log equation, I should see that there's an exponent or asymptote at x equals -1. Last example. I'm starting with the log equation. You can see there's no base. This is common log, so it's base 10. Let's start with, oops, not that. I'll trade out f of x for y. X minus 5 and plus 2. And then on x and y trade places when I find inverse. So I have x equals, I'm getting a delay here. Sorry, it's here. Put the x where the y is, put the y where the x is. X is log of y minus 5 plus 2. That looks crazy. We good with that? And solve for y. I need to isolate here my log. Ooey, that's just going rough for me today. Let's see. Not gonna work out. Okay. Not sure what happened to my internet. Oh, my battery's low. Let's get through this. Solving for y, I need to subtract 2. So I get x. Oh, just a moment, please. Okay. My battery was going out. I'm sorry. I had a trauma. Here we go. I have rewritten this last example as y equals and changed nothing else. Then I exchanged x and y so that I could solve for inverse. I need to isolate the logarithm. So I'll have to subtract 2. So I have x minus 2 equals log of y minus 5. That's a really sad minus. There. And now I need to rearrange this as an exponential equation so that I can solve for y. As I said, here I have a log with no base. No base is common log, that's base 10. So let's rearrange our equation as exponential, and I get 10 to the x minus 2 power equals y minus 5. Still solving for y, so I need to add 5, and I get y equals 10 to the x minus 2 power plus 5. And I'm finished. I can write this as inverse of f of x equals 10 to the x minus 2 plus 5. When I compare my original to my inverse equation, I could look at this original and find that there's an asymptote at x equals 5. And I will have an asymptote for my inverse equation at y equals 5. Please do your practice.